So, welcome everyone. Today we're starting the first two chapters of our electrical engineering course. The goal of this course is to help you to understand what electrical engineering is, why it is important, and how it impacts our daily lives. We will explore together where electricity comes from, how it's protected, how it's transmitted, and how it's used in real application. We will also learn about the main component, electrical network, machines, and power electronics. So the electrical engineering covers many subfields like electrical networks, electrical machines, control and power electronics. So what would you like to know? It's in this model we answer essential questions. What exactly is electrical energy? How do we generate it? How is transmitted safely? How we can convert and control it with quality of service. So, what is the energy? The energy is everywhere around us. It's the ability to perform an action, to move something, heat something, or transform matter. Think of turning on a lamp. The electrical energy is converted into the light and heat. Energy can come from many natural sources water, wind, sunlight, or fuel. Interesting energy is the foundation of all electrical engineering. So, definition of electrical engineer. So, electrical engineering is a branch of applied physics focused on electricity and its application. It includes power systems, electronics, telecommunication, and automatization. So we can connect the scientific theory like electromagnetism, real technology, mathematics, such electrical machine or control systems. If we can part about a practical application, we can see the predicting, the transmitting, the distributing, the transforming, and the management of the electrical energy. So, for the electrical engineer, what does an electrical engineer actually do? They can install, maintain, design electrical systems in all type of buildings, house, hospitals, factories, and offices. They work on lighting, alarm system, surveillance, HVAC control, and energy management. In industry, they also design electrical cabinet, protection systems, and power converter. Basically, electrical engineers are essential for keeping our world powered and connected. If we should talk about a little of history of electrical engineer, we can found five major inventor. So for the first thing, we can talk about the galvanic cell invented by Alessandro Volta, who created the first electric battery called the voltaic pile. Michael Faraday invented the dynamo. The dynamo, it can be applied or it contained in every modern generator. Thomas Edison invented the electrical light and brought the first commercial power. And for the power distribution, mm, it was invented in New York and it is the first commercial electric power. Finally, Mikhail Dolivo and Dobrovolsky invented the three-phase transformator, which can transmit electricity from the direct electricity to the alternative electricity. If we can talk about the role of electrical engineer in the energy chain, we can say that electrical engineering is involved in every step of the energy chain. We will talk about the generation of electricity, the transmission of electricity engineer energy, and the distribution and the use of this electricity. So we have three family: the the electrical network, the machine, the electrical machine, and at the end the command and or the control of this energy. For the electrical network, the electrical energy cannot be stored usually. So we continue. For the electrical network, the electrical engineering or the electrical energy cannot be stored easily. So it must be transmitted from where it's product to where it's consumed. That's why we have electrical network. Systems of power line that transport energy from generation plants to users. The design of the three networks aim to minimize losses and ensure stability. First, we will talk about the electrical power generation. Electricity can be generated from different primary sources. First, the water. Second, the wind using turbines. Third, the heat in thermal power plants burning coal, gas, or oil. The sunlight using photovoltaic panels. And the final natural energy is the biomass using organic materials like wood or agriculture waste. The goal is to make the resource cleaner and more sustainable. For the transportation network, we have a lot of lines. The first line is the very high voltage line, above 100 kilovolt, move electricity over long distance. For the high voltage line, from 10 to 100 kilovolt, supply large industry and urban area. For the medium voltage line, carry power to small factory and transformer station. For the low voltage line and what we use in our home, it's reach our home and applicants. Each level play a vital role in delivering electricity with a quality of service. To move from the very high voltage line to the high voltage line and the model medium voltage line, we should have the switching station. So the switching station can step up transformer increase voltage for transmission, step down transformer it for local or domestic use. So we can transform from this to this and from this to this. Now we will talk about the nature of the tension. We are different between AC and DC. Electrical current exists in two forms: alternating current and direct current. The difference is the next slide. So